Welcome back. Today we are going to enter the LUV tier. To do that, the first thing we have to do is build an assembly line. This is a multi-block which is rather complex to use. But let's start by crafting its parts. Crafting those components is not easy nor cheap, and even our automatic crafting system has issues with it. The main problem is that we do not have a crafting unit capable of handling that amount of materials, so we first make some more storage. We should also make some crafting coprocessor to speed up the crafting process. And once we have added some new and more powerful crafting units, we can finally start working on our assembly line parts. This is going to take some time, so we can do some other things such as farming with us while we wait. We will need those nether stars later on. However, after our brief hunting, we find out that our crafting system hasn't made much progress. And the main issue seems to be that our processor can't keep up with all the items it has to move around the various machines. We could increase the amount of coprocessors, but the best solution is to reduce the amount of tasks our processor has to do. We can multiply the amount of materials in the patterns, so that instead of moving 64 times one dust to the furnace, the processor will just move a stack of dusts once. And, while at it, we can also equip our furnace with better coils, so that it will cook more stuff at once. After editing the patterns and restarting the crafting job, we can see the difference in the speed at which items are being moved to the machines. And, after not much time, we can see that our crafting processors are idling. The reason is that we are crafting thousands of SMD components in a small assembler. 16 at a time. And each batch also takes quite some time. We have already split the load across different assemblers, but it doesn't make a noticeable difference. Even though 4 assemblers should be 4 times faster than 1. We could use a higher tier assembler, but the power consumption would grow exponentially. So we need a multi-block. The first option is the GTNH 1, but that requires ZPM stuff that we don't have access to yet. The second option is to parallelize a stack of assemblers inside a processing array. However, that machine doesn't scale well when we will need to further upgrade it. The third option is using in normal mode the precision assembler we crafted last episode. The issue was that the casings of its structure required an LUV assembler to be crafted. However, if we want it to work in normal mode, we can use the lower tier casings, the imprecise ones. That way, the assembler will fully live to its name. After preparing the patterns, we craft just the minimal amount required to form the structure. And to make that thing work fast, we shall have a 16 amps energy hatch. That way, it will work twice as fast as 16 IV assemblers. And you can already see how charging its personal buffer takes a toll on our main battery. Once everything is ready, we assemble the assembler structure. We fill all the non-mandatory casings with cheap buses. And now we can turn that thing on and see how little it takes now to make hundreds of SMDs. The last bottleneck is our circuit assemblers, so we add a couple more. One for each circuit step. And then we can take a break and AFK a bit. Or maybe we could just farm more nether stars. After the quick break, our assembly line is ready. This multi-block can be built with different lengths. Every additional slice adds space for one more input item. We can also rotate it using a wrench to build it vertically and have it use less space. And for the moment we are going to build one of medium length. We quickly add the energy input and then we move to the bottom, where we will have to plan a way of automating that thing. Since each items goes in a different slice, we use the smallest buses to push items up. To fill the items in, we use a dedicated AE2 network, where we drop items inside an interface and they get moved with storage buses to the machine. And if we do not want things to go into random places, we have to sort the storage buses' priorities. We are not sorting the items with a filtering mechanism because many recipes require the same items but in a different location layout. Once we have fully configured the priorities, we add an interface connected to our main network to automate the crafting requests. Now we can slip inside a crafting pattern and see if everything works as expected. Once all the materials are prepared, they are correctly inserted into the slots. However, once we try to turn on the assembly line, we realize we have forgotten something. Other than the crafting materials, the machine also needs the instructions on how to build things. To get those, we have to do some research by scanning the lower tier of the thing we want to assemble. We quickly move to our EV scanner to do that, and we find out it will take a quarter of an hour to get the instructions for our assembly line. And we have to do that for every LUV component. Anyways, once our research is done, we can bring the data to the assembly line, which will finally start working. One motor is almost useless, so we shall start crafting more. But, while it looked like everything was fine, one big issue was starting to build up. The items are being pushed to the assembly line, and since some buses were already filled, the overflow went to the wrong input slices. To avoid such thing, we have to add a blocking card to the assembly line network. And enable blocking mode on the interface with a pattern. And with that we can see that the motors are being crafted one at a time, with everything being perfectly dosed. Now we can scan the other components and bring the data to the assembly line. However, there is only one space in the assembly line controller. But we can add a data access hatch to increase that amount. The next issue is that some components have too many ingredients to fit our pattern terminal. Of those, we manually craft just the bare minimum amount to upgrade our pattern terminal to a fluid processing pattern terminal. This one has 32 input slots instead of 9, more than enough for any assembly line recipe. We quickly drop in the new patterns and now we can move on to the next quest. Which is probably going to be, in the previous tier, to reach new planets with new materials. And that means crafting a new rocket, whose plates must now be assembled in an assembly line. We quickly set up the new crafting patterns, but then we run into a new issue. Everything got stuck because the plates did not split into the two buses. To fix that issue, we are going to use one simple solution. We prepare some molds that will rename the parts before sending them to the assembly line. To use it we make a pattern that, with help of a press and the previously made mold, will rename the items. Now we can edit the plate pattern to use the two different items that won't merge. And with that, we can now start making complex assembly line recipes in an easy way. Once everything is in the correct place, we can start crafting our rocket plates, which we use to make the Tier 4 rocket. While that is being built, we can also prepare a new kind of miner, the ore drilling plant. That is the multi-block version of the small miners. It has several buffs but it requires to move a bigger structure and need drilling fluid to work. And while that is crafting, we can get a better tool for locating minerals, an electric prospector. This thing can also be used to check the pollution in our base. But its main usage is to see the disposition of underground resources. And once we locate a good mining spot, we can build the ore drilling plant, which is going to mine all the minerals in a huge area, one chunk at a time, layer by layer. And to avoid getting overwhelmed by its output, we can throttle it by decreasing the amount of drilling fluid we send. And now we are ready to start working on the LUV tier, but that's for the next episode. Bye bye.